Perfect. We're going to keep powering through, and this problem is very similar to the previous one. I would even point out that I would start with part B and find cosine of theta, which is the reciprocal of secant, so negative 2/3. So when I go back to part A, it makes more sense, at least to me, to identify where cosine is negative and tangent is positive. So cosine is negative in the second and third, tangent is positive in the first and third, so where they overlap, none of these other ones. So we're looking at quadrant 3, and I would even take it a step further and actually write out cosine, where cosine is adjacent over the hypotenuse, and this is not a Pythagorean triple, so you actually have to work it out. And negative 2 when you square it's the same as positive 2. I'll even use y for the y coordinates, up and down, is equal to that. So 9 minus 4 gives me 5, and when you square root that, it will give you the y coordinate. And it might make helpful to write as negative square root of 5. So yeah, from there I would do sine, just kind of out of habit. Sine's opposite. I guess I should put the angle is made with the x-axis. So opposite of theta is negative 5, hypotenuse is 3. So then cosecant, the reciprocal of sine, just flip that. And I like to rationalize because I don't know what your next year teacher will make you do. So I think that's useful to know. And then tangent. Well, negative over negative is positive. Opposite is the root 5. Adjacent is 2. Yeah, so it's satisfying everything that we know so far. And then cotangent would be the reciprocal of that. And again, I would rationalize it out of habit. And it's good practice. So I'd do the same thing with the next one. I would first identify, that cosecant is the reciprocal of sine. So that would be 3/7. But what I really care about is that sine is positive to help me do part A. So if sine is positive, we're in the first or second quadrant. And as a reminder, cotangent being negative is the same thing as saying that tangent of alpha is negative. So that's the first or fourth quadrant. Not the, did I say first? Second or fourth. Anyway, it's quadrant 2. And from there, I would go ahead and draw that out. That sine being alpha is opposite over hypotenuse. And from there, I can do a Pythagorean theorem, 3 squared plus, I'll call it x for being that coordinate, is equal to 7 squared. So that's 49 minus 9, so it would be 40. The difference with this is I would rationalize, and I don't know how you learned it, but I typically teach it of factor trees, and you look for pairs. So the x coordinate would be negative 2 root 10. And if any of you are sitting there and saying, why didn't you break down 10? Well, I could have, but there's no pairs. Yeah, so that's where we're at. So now cosine would be negative 2 root 10 adjacent over the hypotenuse. Where are we at? Secant then, the reciprocal of that, I would flip negative 7 over 2 root 10. But again, I could rationalize that by multiplying by root 10 over root 10. And I'll show this in a different color. So that would give me negative 7 root 10. Root 10 times root 10 is just plain 10. And then 2 times plain 10 would be 20. So then from there, I can do tangent of alpha, which is opposite over adjacent. Negative 3 over 2 root 10, but similar work as what I did for secant would give me negative 3 root 10 over 20. And then a cotangent of alpha would be, I would just reciprocal this one, negative 2 root 10 over 3. you could reciprocal this one, but then there'd be some simplification to do, which is partly why some people don't rationalize denominators. And I get it. It's just not typical. So as we move on to the next exercise, we're looking at angle B, which is in quadrant 2, and we have this line, which would actually probably be beneficial if you actually solve for y. So subtract negative 2x over. So y would equal negative 2/5 x. The plus 0 there is just to make it so theta goes through the origin. But all I really care about is that we're in quadrant 2. And remember, its slope is y over x. So the y coordinate would be 2. And then this x coordinate would actually be negative 5. I know I wrote it the other way. That's just how it happened, like down 2, right 5. But because we're in quadrant 2, that puts a wrench in that. So if you do the Pythagorean theorem, 2 squared plus 5 squared is equal to c squared. So we're looking at 25 plus 4 is 29. So they're looking at the square root of 29. So as far as our answer goes, the least, I don't really like this. Let's just find all three of them. I was trying to be fancy. So let's find sine of beta first. Well, sine is opposite over hypotenuse. And then cosecant is the reciprocal of that. So it'd be root 29 over 2. And then tangent would be opposite over adjacent, or sine over cosine. So tangent, let's write it right here, would be 2 over negative 5, or negative 2/5. But as we look at this from least to greatest, just a reminder that the least, negatives come before positives. So the least is tangent of beta. And then, I guess I should write it down in case you don't. I'm saying beta for this letter. And then as you compare the other two, because they're both positives, so they're larger than this negative value, I would compare the square root of 29, because the square root of 29 is about 5 point something, a little bit bigger than that. Well, 2/5 is about 0.4, so definitely a small number compared to this one. Well, 5/2 is bigger than 1. So this would be my greatest. And if I cared to have better notes, I'd probably list them in order. You know, like write tangent of beta, then sine of beta, then cosecant of beta. But I have faith that you can do that and keep this video somewhat short. Yeah, so as we look at the next one, I think this is the last. I'll double check that it is. Okay, so tangent is negative. So they're not asking what quadrant, but that is important. Tangent's negative, so that's either in the second or fourth. But secant is positive. That means that cosine must also be positive. So that must mean that we're in the fourth, not that one. Not that one. Not that one. Cosine would be positive over here, but anyway. Yeah, so what I would do next is go ahead and draw that. And tangent, by definition, is opposite. And it's negative for the y-coordinate over adjacent. And it's a 3, 4, 5 right triangle again. Don't forget about your Pythagorean triples. So as we look at that, then we can quickly identify that cosine of theta must be adjacent over hypotenuse, and it's positive. And then cosecant is the reciprocal of sine, so it doesn't ask you for sine, but you might as well tell, if you're showing your work, sine would be opposite over hypotenuse. So then cosecant would be the reciprocal of that, negative 5/4. And I believe we are done. You should be ready for the homework.